Now I'm going to discuss another paper about ownership. It's product innovation transfer under passive partial ownerships holdings. So this paper is published in Economics Letter, B+ Journal. The authors are Papadopoulos, Petrakis, Skartodos. So this paper is quite similar with the paper I've discussed in my YouTube. It's Leonardo is the first author, the second author, and the third author are the same. So we investigate the incentive of a high-quality firm to transfer for free its proprietary product innovation technology to its standard quality rifle, on which it has passive partial ownership holding. In this paper, we are going to discuss about two firms, firm 1 and firm 2. Firm 1 is a more efficient firm and firm 2 is less efficient. So that is why the author says standard quality rifle. In this case, firm 1 owns the share of firm 2. But then firm 1 transfer the innovation, product innovation. So we'll see later. There is a contemporary resurgent interest from researchers and policymakers on the impact of partial passive ownership holdings, usually denoted as PPO, or else silent financial interest. When we discuss about passive ownership, it means silent interest, where the acquiring firm doesn't have the control right to determine the rifles or the acquired output decision. So that is why we call it silent financial interest or passive ownership. So the anti-competitive effect of PPO are well established. We can see in those papers in Reynolds and Snap 1986, Solop and O'Brien 2000. They find in the paper that PPO is actually anti-competitive. The effects include the contractions of the output and higher consumer surplus we can see in Scalms 2018. And there are some papers discuss about PPO. So this paper examined the incentive of a high-quality firm to transfer for free its proprietary, non-contractible product innovation technology to its standard rival on which it has a silent financial interest. So means that firm 1 as a high-quality firm will transfer its technology to firm 2. And in this case, firm 1 owns partial of firm 2's shareholding. Stage 1, the high-quality firm decides whether to transfer its technology to its rival, in which case both firms will produce horizontally differentiated goods of equally high quality. So this means when firm 1 transfers its technology to firm 2, then now both firms have the same technology, means that they will produce high quality product. In stage 2, firms compete a la Cournot. We saw that there exists a critical ownership share above which it is profitable for the high quality firm to transfer its technology to its partial owned rival for free. The meaning of these sentences is The meaning of this sentence is Firm 1, as a high-quality firm, will transfer its technology for free to Firm 2 if and only if we can see later the degree of ownership in some critical value. So this implies that Firm 1 doesn't want to really give the technology to the rival. The condition only if the ownership from the rival is in some value. This share is higher the less horizontally differentiated the goods are and the larger the goods initially quality difference. So intuitively, the technology transfer intensifies competition as both firms now produce high-quality goods. As the high-quality firm has sufficiently high share of the standard quality rifle, this paper used standard quality rifle for Firm 2, so then it enjoys part of the later incremental profit stemming from the technology transfer. So finally, we show that our findings are qualitatively robust to the mode of competition. In our paper is in line with the recent scanned literature that stresses the bright side of PPO and in particular the link to R&D investment and innovation. We can also find in say Legia and Spiegel 2015, Lofes and Fifis 2018, so that PPO may facilitate cost-reducing investment, inducing lower price, higher welfare under price competition with homogeneous goods, and under both price and quantity competition with differentiated goods, respectively. Okay, we can find many literatures talk about PPO. So here we can see in Reynolds and Snap 1986, it can include the transfer tacit technology that increases rifle costs and hence consumer price. So papers above establish positive welfare effect on PPO by hinging essentially on the diffusion of the cost-reducing technology across interlinked firms that increases industry efficiency and outcomes and the anti-competitive effect of PPO. In contrast, we consider a horizontally and vertically differentiated good oligopoly with both quantity and price competition. It means this paper analyzed both Cournot and Bertrand competition, in which the transfer of the product innovation creates value in the market by directly affecting consumers' utility. I'll continue to the finding. So the findings can explain some stylized facts of the product innovation transfer in the technology industry. We can see here this includes the 2010 purchase of 19.9% of Monsanto in grains, a rival cereal breeder in Australia, explicitly based on product innovation transfer of germ plants of breeding. We can also see footnote 2 and 2001 purchased about 15% of Japan Telecom by Vodafone. So Vodafone purchased about 15% of Telecom. The role of critical ownership level of successful product innovation transfer is explicitly illustrated in the Volkswagen-Suzuki alliance in 2009, which took place on the purpose of transferring innovative product technology and diesel and hybrid car engine to Suzuki. Okay, I think this paper is quite good because this paper provides some examples about PPO and transfer technology. Now we can continue directly to the model. We consider a Cournot duopoly first in the very beginning model. We consider a Cournot duopoly in which firms produce horizontally differentiated goods of different quality. The authors cited from Sutton, 1997, we assume the following linear inverse demand system. Okay, we can see equation 4. So this is the inverse demand. This is the willingness to pay. And we can see equation 4 or footnote 4. The demand system derived from a quality augmented version from Singh and Fivis quadratic utility. We can find the inverse demand here in equation 1 from the utility here. We can take the first derivative with respect to quantity, and then we can find the inverse demand. If any one of you has problem to find equation 1, you can leave a comment or a question. Here, PI, QI, UI are firms. So PI is the price, QI is quantity, and UI is the quality. Gamma from lower than or equals to 1 and higher than 0 measure the degree of horizontal product differentiation. Means that when gamma is closer to 1, the firms are more homogeneous. However, when gamma is close to 0, the firms are more differentiated. The product of the firms are more differentiated. Okay, there is an explanation here. The higher gamma, the less differentiated the goods are. Firm 1 has a proprietary innovative technology that allows it to produce goods of a high quality, U1, while the firm 2 produce a good of standard. So firm 1's good is a high quality good, and for firm 2 produce standard quality, U2. So we can see here that the quality U1 is higher than U2, higher than 0. And then without loss of generality, we assume that U2 equals to 1 and U1 equals to U greater than 1. Okay. Then you measure the relative quality difference between the two goods. Now we have here the high quality firm 1 has passive partial ownership holding PPO in the standard quality firm 2. So as I draw before, this is firm 1 and this is firm 2. So firm 1 own passive partial ownership holding of firm 2. We denote as, okay, the authors denote as S. So S is the share. Okay. Therefore, we can see the objective function of both firms. So for firm 1, as a high quality firm, we can see that this C is the marginal cost production, P minus C times Q1 plus S is the share times the profit. So, okay. So this one is, we can say this one is operating profit of firm 1, and this one is operating profit of firm 2. Firm 2 share partial of its ownership to firm 1, so that is why we have the here plus. And then we minus here because the share reduce firm 1 total profit. Firm engage in two-stage game which observable action. So in stage 1, firm decide whether to transfer for free. We can see its innovative technology. We can see footnote 6. This production innovation technology could be non-contractable because it incorporates tacit knowledge that cannot be transferred as a free. In Ghost and Morita, technology licensing is always profitable in our setup, and it always would not be of much interest. Okay. Then in stage 2, firm compete in quantities. So timing reflect that technology transfer is an irreversible long term. The explanation here is that the first stage is actually the long term decision. So that is why in the first stage we have the transfer for free or not. In the second stage, Cournot. Okay, there is an assumption here U lower than 2 over gamma. So this assumption here to make sure here we assume that the relative quality, this is the relative quality difference, is not too high, such that the standard quality firm output later on we can see from Q2 should be positive, so that firm 2 exists in the market. Yeah, this assumption is to make sure that firm 2 produce positive output. Now we continue to the section 3, equilibrium analysis in stage 2. So we solve the game backward induction. We start from the Cournot competition. There are two possible subgames depending on decision taken by firm 1 in stage 1. The high quality firm 1 transfer its product technology to the standard quality firm 2 or not. In the no technology, later on we can separate them. One is with no technology transfer and the second is technology transfer. We denote no technology as N. So the firms sell goods of different quality. Firm 1 will sell high quality goods and firm 2 will standard quality goods. In technology transfer, because firm 1 transfer the technology to firm 2, so both firms produce or sell the same quality. Now we discuss no technology transfer. Firms simultaneously choose output to maximize their respective profit, as we given in equation 2, the reaction function of firm 1, and this is the reaction function of firm 2. And we use alpha tilde for A minus C. Okay, and C is lower than A. Clearly, the higher the share of firm 1 owns in firm 2, we can see from here that when share is high, firm 1 will produce lower because we can see here minus. Therefore, the less aggressive it becomes in the product market. So we solve the reaction function, we can find the equilibrium here under no transfer technology. Okay, here. As we mentioned before, assumption 1. Assumption 1, the relative quality difference U must be lower than 2 over gamma. We can find it from here. So that firm 2 produce positive. Note that Q1 n larger than Q2n unless given as U is too low, Q1 minus Q2n, then we can find this critical value. Then we can say that Q1 n larger than Q2n. On the other hand, as firm owns the share of rival, it behaves less aggressively in the product market, leading to a lower output. On the other hand, it sells more of a high quality goods that is of the higher value of consumer. If the relative quality difference is too low, the second effect dominates and firm one has a higher market share. We continue to section 3.2, technology transfer. Firm 1 transfer its technology to firm 2. Okay. Now U1 equals to U2 equals to U. In stage 2, because now we discuss about Cournot, so we can find the reaction function of firm 1 under transfer technology. T stands for technology transfer, and this is for firm 2. It can be verified that the reaction function of firm under technology transfer is higher than no technology transfer. The technology transfer shifts both reaction function outwards, effectively increasing aggregate output. As above, the higher firm 1's share in firm 2, the less aggressive it behaves. Okay, means here we can see as higher, firm 1 will be less aggressive. Okay, we solve the two reaction function, we can find the equilibrium here in equation 4. Okay, here, notice that prices are qualitatively independent since quality is uniform across firm. Means that we can see that price here is independent of U because now both firms are symmetry in quality. The price of both goods are independent of U. More importantly, the latter implies that Q1 and technology transfer is lower than Q2 technology transfer. And for the price, we can find that the price of good 1 under transfer is higher than the price of goods 2 because the quantity of firm 1 is lower. Therefore, the price of goods 1 is higher. So firm 1 now has a lower market share and sets a higher price than the rival firm 2. Okay, this is the intuition under technology transfer. Now we continue to section 3, product innovation transfer. In this section, we want to see whether firm 1 wants to share its technology for free to firm 2. In state 1, firm 1 will transfer its innovation technology to its rival only. We can highlight this one only if, by doing so, it increases net profit. Otherwise, firm 1 doesn't want to share technology if its profit doesn't increase. We can find proposition 1. If the share is high enough, higher than SC, then firm 1 will transfer for free its product innovation technology to firm 2. where we can find that SC is here. This is the value. I think we can find the SC from the appendix. Yeah, this one. We taking the difference, the total profit after transfer minus total profit no transfer. So we can obtain this value, and then we can solve this and find SC. So if if S is lower than SC, means the profit after transfer is lower. So there is why firm 1 doesn't want to transfer. Okay, we can see here that proposition 1 states that if the high quality firm 1 owns sufficiently high share of its standard quality rival firm 2, then it has incentive to transfer for free its product innovation technology. Okay, we can also check the minimum required share here. SC, this one, SC, is increasing with gamma. As we know, gamma is the degree of product differentiation, right? Or the alternative quality difference increases. SC is also increases with quality. Therefore, as long as the relative quality difference is low enough, U lower than 1.1, the minimum required share is below 1/2, in which case there is technology transfer for all values of gamma. So as long as U is lower than 1.1 and S is below 1.2, there is always technology transfer for all values of gamma. For higher value of U, such an ownership share exists only if the products are sufficiently differentiated. We can see footnote 7. Here, in particular, if U is larger than 1.1, there exists a gamma head is decreasing in U. Okay, we can see from here. Okay. Thus, the less differentiated the firm's products are, and the more innovative the product innovation technology of firms 1, the more stringent are the conditions that allow the technology transfer. We can also discuss proposition 2 here. Let's S larger than SC. Okay. The transfer of product innovation technology increases aggregate output, industry-wide profit, increases consumer surplus, and social welfare. Under technology transfer, both firms produce goods of high value to consumer, and thus their inverse demand function shifts out. Okay. This in turn leads to higher aggregate output. In addition, firm 2 faces a relative higher demand increase than firm 1, means that firm 2 has higher demand. Increase in the quality of firm 2 will increase the price of firm 2 higher than the price of firm 1. As firms now produce goods at equal quality, competition among the firms become fierce or become more competitive. Okay. Yeah, so under technology transfer, both aggregate output here, aggregate quality increase in the market. As a consequence, consumer surplus increases. Okay. The latter, coupled with higher quality wide profit, leads to an increase in social welfare. So actually, this is why the purpose of this paper, they want to see if there is a transfer technology, whether consumer surplus and social welfare are higher. Okay, now we can see under Bertrand competition or under price competition. The author say that they want to check the robustness, whether transfer technology can increase consumer surplus and social welfare under price competition. So we next consider that the firm compete in price. We can substitute this into the profit, the total profit of both firms. Equation 5, we substitute equation 5 into equation 2. Okay, then